Hello everyone. In this lecture, we'll go on to study about Kubernetes. In the previous lecture, we have already studied about the history of cloud computing, and the various microservices in cloud computing with an example. So in this lecture, we'll be learning about Kubernetes, the benefits of using Kubernetes, what it means, uh, and a real world case study of Kubernetes implementation, uh, and the workflow for a Kubernetes engineer, and other things along with that. So let's begin this lecture. So what is Kubernetes? Kubernetes is an open source container orchestration platform. So we'll be breaking down this jargon into different words, and we'll be learning using the DevOps cycle, which I have given using the image. So if we are building any application, we'll be having multiple phases in that development. So the first phase is planning, in which the different stakeholders, developers, team members, product owners will lay down the development of the application. In the next phase, the developers will be coding and they will be committing the changes to the code base using Git. In the build phase, we'll be building multiple containers. The containers will be having the microservice inside it using Docker. And then we'll be testing all of these components using automated testing framework like JUnit, SonarQube, Checkstyle. And then we'll be releasing it onto the market for the use by users. We'll be deploying our code base, we'll be deploying a server, data storage units using Amazon Web Service, for example. And then comes the part of Kubernetes in which we'll be operating our application using Kubernetes. We will learn how we are doing that in the upcoming slides. And then we will be monitoring the user interaction analytics statistics using Nagios. And then if we want to make any change, the feedback will be sent to the team members and they can still plan. And then this cycle goes on and on. So basically, Kubernetes, it is an open source, so it can be used by any person. You don't have to pay for it. You can directly use it. And containers. So any of the microservices which you are building, they will be enveloped using a container. And orchestration means the way we are handling managing the containers. And it is a platform for doing all of these stuff. So what it basically does is it automates the deployment, scaling, and management of containerized applications. So now what we are doing is we are shifting from the monolithic paradigm and we are building microservices applications in which we are breaking down our application into several small independent applications which are known as microservices. And what we are doing is we are making containers. These containers are containing that microservice. Like suppose we have 5 containers. So one container will have a payment service, one will have authentication service, one will have billing service, one will have recommendation service, one will have logistics service, and on and on. And there will be one master node which will be redirecting the request made by the users to the particular containers to get the service. So everybody will be learning more in the next slides. Then what are microservices? We have already told, but I will give you a brief example. So it is an architectural style in which we are breaking down our applications into several small applications. Then all the different microservices are mostly coupled together. So it means that even if we are taking a single microservice, we can deploy it onto the market. We can integrate different components into it. We can scale it. And these are also loosely coupled, so they can interact with each other also. The next line is the same. And then why we want to use Kubernetes for microservices. So like you'll be having an application, building one software. So there is a tool in Kubernetes called as horizontal pod autoscaling. So first we need to understand what is a pod. So a pod is the basic unit of Kubernetes. It will be containing the containers, and the containers will be containing the microservices. So depending on the user traffic, we can make replicas for the pod. And if the demand is high, we can make several replicas and it will be the load will be balanced, and the users will be getting the service they want, the resilience. So even if some of the pods break down due to any system failure or any disaster, some other replica will be working, ensuring that the user will get high availability of the services. And this term is also known as self-healing. Then deployment. So will be when we have deployed our application onto the market, we also want to make some update, correct? So uh, while we are updating our containers, users can still uh, make use of the services. So this is one of the most important use of Kubernetes. So while we are making the change to our containers, users can still use, right? So there is no downtime, and the application is available to use 24/7. And while we are making any update, in case of any error, we can still roll back and we can go to the consistent previous system state. Right? So we'll be having a cluster, and in the cluster we'll be having many pods. All the pods will be containing the containers, and the containers will be having their microservices. So if we are making any update onto our cluster, the system state should be consistent throughout. So if during the update, if there is any erroneous state, so that will be transient due to Kubernetes, and we can roll back to a previous consistent system state. So this is what it means by rollbacks. Okay. Then resource management. So according to the utilization and allocation, there is one tool in Kubernetes called as vertical pod autoscaler. So what it means that now uh, vertical means in a single system we are increasing the resource, and horizontal means we are adding multiple resources. Uh, as horizontal is cheaper, economical, vertical is not, but we still need vertical scalability so that if we are working on a single pod, the resource allocated should be enough so that my service is done. Whatever request I'm making, it should be satisfied. Uh, Now we go on to studying the overview of the Kubernetes architecture. So there are master components and there is one node component. So the master component will be controlling all the cluster in our Kubernetes architecture. So what we will be having? API server. So this is the communication between the user, the team of developers, and the Kubernetes engine. So we'll be having one application programming interface in which we can manage our cluster. We can set the specification, we can configure the pods in a certain way, and all the config maps and secrets are also laid down. So that is the use of API server. It acts as an intermediary between the user interface and the operating phase of the application. Then etcd. So here we are storing the configuration for the cluster, configuration for the pods as well. So it is in form of key value pair, just like JavaScript object notation, and we are storing the cluster data here. Now we are having a controller manager, which is basically needed for cluster management. So it maintains that the state of the cluster is movable and it is moving from one consistent state to another. Schedule. It assigns the workloads to nodes. How? So the users will be wanting some service out of the application. All the requests will be uh, coming to the master node, and the master node is responsible for assigning the workloads to the different nodes. So any billing service you need, it will be giving it to say container 3 or pod 4, something like that. So now we are coming to the node components. One of the basic component in Kubernetes is kubelet. So what it does, it maintains the communication between a pod and the master node through proxy. So suppose we are making the replicas for our pod, proxy is there in case any pod fails. So the load can be balanced using the replicas of the pod. Now we are having the container runtime. With Kubernetes, we can have, there are different container runtimes like Docker, and one more is called container, and one is called CRI. So it is basically used for running the containers and the microservices inside it. Especially Docker is very famous in the DevOps cycle as it is used for making containerized applications. So this was the overview of the Kubernetes architecture. Uh, okay, so now we are coming to the key concepts in Kubernetes. Pods. It is the smallest deployable unit in Kubernetes, as I've already told you. Now, a pod can contain one or more containers. What means, like, a pod can contain one or more microservices, then services. So now we can define a set of pods, right? Now in a cluster they will be having several pods. So we can group the pods together to define one logical unit, and that logical unit is needed for performing the service. Right. Like we can be using one billing service and analytical service, and both of these pods are helping to perform a certain service in our application. Right. So in the services, it can also manage the deployment and scaling of pods as well. As I've told, with the vertical pod autoscaler and the horizontal pod autoscaler, and it can manage the deployment also. So within the cluster, each pod will be having their own namespace. So when we are writing the code, so the functions and the classes which we are defining for any containerized application, they it now be exceeding the namespace. Now the config maps and secrets. So it will be storing the configuration data and all the secret confidential information regarding the cluster so that it can be accessed by any third party and there will be no immaculate malicious intrusion into our cluster. Now deploying microservices with Kubernetes. This is the main important part of Kubernetes. So there are four steps in there. First is containerization. What we are doing, we are putting our microservices in particular containers for consistency. Now CI/CD means continuous integration and continuous deployment. What it means that suppose we have some application onto a market. Now we want to do some update. So we have made those updates in our local host, but we want to integrate that to our application which is currently in the market. We can continuously integrate our local host version of the application and the market present version of the application. And deploying means deploying that application to the market. And what we can do, we can automate the building process, we can automate the testing of those components, and we can easily automate the deployment. Right. Now, Kubernetes domain name server. What it does, it discovers the services. Like we are asking for any service out of the application. So it will be discovered which pod inside the cluster is responsible for performing that service. And it will be sending that request to that particular pod. And now load balancing. So we are having multiple instances of the service. So we can distribute the traffic accordingly. This was the deployment of microservices with Kubernetes. Now, example deployment workflow. So, like I told you in the DevOps cycle, first we will be writing the code. Developers write and commit the code using Git. Now, we are building. We are building the different containers and we are putting the different microservices using Docker. And this is the part of the CI/CD pipeline. Now, test. We can run automated tests using the different tools like JUnit, SonarQube, and then we can run our tests on the components to check whether they are conforming to the specification the stakeholders, the product owners have specified in the specification document. And then we'll be deploying. So the different containers will be deployed to the cluster into the pods using Kubernetes. And now we are monitoring. Right? We track the performance and the issues with the containers, and we are giving it back to the planning stage of our cycle to check for any changes. So the real world case study is of Spotify. So Spotify is a music streaming platform which is widely renowned, and what happened is that it was first following monolithic uh, programming paradigm. So, so it transitioned from monolithic to microservices. And what does microservice offer? It offered better scalability and flexibility. So now the different microservice can handle the different services inside Spotify. For example, a different service can handle the playlist, and a different service can handle the recommendation. What was the challenges the Spotify developers were facing before employing or adopting Kubernetes? They were facing scalability issues. So as the users grow, there were scalability issues, and there was more downtime for the application. There was deployment difficulties. So if they were making any updates, so they had to shut down the operation, and after making the integration, they were deploying, and the high cost due to the upfront architecture cost and service disruptions also. So what was the benefit after adopting Kubernetes? So now we can easily scale in or scale out our application without any problems. There were seamless deployments. So even if we are updating, we can still listen to music without any problem. There were cost saving because there was no downtime. We were saving a cost into that. And also, as there was high availability and there were replicas of the services, there was some high availability for the music streaming and improve resilience to any threats or any errors that can be made in the system were removed or averted. So a quantitative uh, analysis for the Spotify development team after the adoption of Kubernetes is that there was 50% faster deployments, 99.99% of time, 30% post reduction, and 10 times more traffic handling can be done. Here we can see the real usage of Kubernetes, how a very big platform like Spotify can use Kubernetes and they can increase the profits. So this is the need for microservices. This is the need for Kubernetes in the DevOps cycle for developing any application. So coming on to the conclusion is that Kubernetes provides a robust tool for managing the microservices and cloud computing. And what it does, it enhances the scalability, resilience, and deployment efficiency of our application. So what are the next steps for any software engineer or any person who has an interest in Kubernetes? He should get a hands-on practice with Kubernetes. As it is a later part, you have to move through the DevOps cycle from Git and then Jenkins and then a Docker and then other tools. Then we can get the hands-on practice with Kubernetes, and they can consider Kubernetes and they can integrate that uh, in their next microservices project. So in the upcoming lectures, my teammate Atul will be giving you hands-on walkthrough in the Azure Kubernetes services and Azure Container Services, and he will be telling you more about Kubernetes. So that's all from my side. Thank you.